seems blurry, doesn't it? Let's just give it a minute. Okay, so now we're into confidence intervals. So, what is a confidence interval? It's an estimate of the value of the population mean or population proportion. So you're going to do two types of confidence intervals in this unit, one for population mean and one for population proportion. So it's an estimate in interval form with an associated level of confidence. It gives a list of plausible values for the parameter, which is either the population mean or the population proportion, based on the value of a statistic, a sample mean or a sample proportion. So what does that mean? So sometimes when you take a sample and you calculate the mean of something, say average height of York Mills students, we can't say that the mean of the sample equals the mean of the population. We can't do that. But we can come up with an interval for population mean or population performance based on a sample mean and sample proportion. Yeah? Okay, so for example, the general form of a confidence interval is estimate plus or minus margin of error. So we go, the estimate is our sample mean minus the margin of error, and we'll talk about how to create that, is less than the mean, is less than the estimate, plus the margin of error. Okay, so that's what our confidence interval will look like. We're estimating the mean, thank you, but we are using the sample mean minus some margin of error, is less than the population mean, is less than, say, the sample mean plus the margin of error. So it would actually look like this. X bar minus our margin of error is less than mu is less than X bar plus our margin of error, where that's the symbol for sample mean. Okay? Now, it's similar for proportion. For proportion, we're going to go p hat, which is the sample proportion, minus the margin of error is less than the population proportion is less than p hat plus some margin of error. Okay? And we'll do examples of that. What does margin of error mean? Well, it's the maximum amount that a statistic value will differ from the population value for the middle 95% of the statistics. Note, changing the level of confidence changes the percentage of interest. So we're going to be talking about several types. There are many types of confidence levels. On the test, we're just going to use a 95% confidence level. Okay? So this is very important for the interpretation of a confidence interval. Confidence interval interpretation. We are 95% confident that the true mean is between your estimate minus the margin of error and your estimate plus the margin of error. So here's maybe a more specific example. Let's say we find the sample mean to be 97.7. Well, the sample mean, we can't say the sample mean equals the population mean, because the sample just has a few values in it compared to the population mean. But what we can do is say we can find an estimate for the mean based on the sample mean plus or minus a margin of error. So let's say we have a margin of error of 5. The most that X bar could differ from the population mean for the middle 95% of all possible x values. So in this case, we go 97.7 minus 5 is less than the mean, is less than 97.7 plus 5. Or in other words, this is 92.7 is less than the mean, is less than 102.7. So we can say, if it's a 95% confidence interval, we can say we are 95% confident that the interval from 92.7 to 102.7 contains the true population mean. And that's what it says here. So why don't I see if I have a highlighter, and let's highlight the most important stuff. This is very important because you're gonna calculate a confidence interval, and I'm gonna ask you to interpret it, okay? So a 95% confidence interpretation is that 95% of all possible samples yield intervals containing the population mean when computed using the same procedure that was used to obtain the 95% interval. So we'll do examples of that. So here is the confidence interval. So for your test, just memorize that one. If you want a confidence level of 95%, we're going to use the Z alpha over 2 of 1.96. And these are the formulas you need to just memorize, okay? That one. And so just so to help you remember, X bar is your sample mean. Z alpha over 2. For the test purposes, it will be 1.96. We're going to use a 95% confidence level. Sigma is your population mean. And N is your sample size. Okay? And nu is the population mean. Okay? Now, if we're doing a population proportion, P hat is the sample proportion. Q hat is just 1 minus P hat, right? Yes. Sorry? Oh, you have 2 here, yeah. You mean that one and that one?
No, I mean the population mean on the left, O and sigma U.
I'm sorry, I don't get what you're saying.
I'm wondering about these, because wouldn't these be the same thing?
Oh yeah, this is population standard deviation. I'm sorry. Thank you so much for that. Standard deviation. So let me check that. That's sample mean, population standard deviation, and population mean. P without a hat is population proportion. And Z alpha over 2, I'm only going to ask you for the 95%. Okay? Okay. So P hat is the proportion sample. This is an estimate of the population proportion P. So this part here is called your margin of error. All these boxes are margin of error. Or ME for short. So, the next to calculate, well, if you want a certain confidence interval with a certain confidence level, what sample size should we use? So, the sample, we're going to use this to find, that's margin, just to make sure you know, that's a margin of error, that's margin of error for proportion, and that's margin of error for proportion. Okay. Now this helps us get the sample size. So these are other formulas you need to know. And we all would notice the rule, we almost round up. Where did that come from? Well, for means, the margin of error is equal to this. So you can solve it for n. So margin of error equals Z alpha over 2 sigma over square root of n, and we can solve for n. So square root of n is equal to Z alpha over 2 sigma all over the margin of error. And then you can square it, so n equals Z alpha over 2 sigma over the margin of error squared. In case it's coming from the interval, the calculations for confidence intervals. This one for means, and this one similarly, margin of error, if you look on the confidence interval formula, is equal to Z alpha over 2 square root of p hat q hat all over the square root of n. So if you solve for n, you get square root of n is equal to Z alpha over 2 square root of p hat q hat all over your margin of error, and then you just square it. N is equal to, the square of p hat q hat is p hat q hat times Z alpha over 2 over margin of error squared. So if you know this, you can find out your sample size formulas just by using that. So let's do an example. A politician conducts a poll to see how the public is supporting her latest initiative. The poll comes back with a 62% approval rating. So is this a mean or is this a proportion? Are they saying average is 62? If you see a percentage, it's most likely a proportion. 62 out of every 100 people approve of her. This pleases the politician. However, the poll has a margin of error of 30%, 19 times out of 20. So 19 times out of 20 is 95%. So we're looking at a 95% confidence level. Okay, right? How should the politician read the results of her approval rating? Okay, well, let's see. We are 95% confident that she has a margin of error. Well, let's look at this. 62%, that's the margin of error, 30%, is less than the population proportion, is less than 62% plus 30%. Or in other words, 32% is less than P is less than 92%. So, how would we interpret that? We are 95% confident that the, that the interval 32 sin P is less than 92 contains the true population proportion. Okay. Based on this information, how many people did she likely poll? Okay, so we're using the, to calculate the sample size she might have used, we're using that formula there because it's for proportions. N is equal to P hat Q hat Z alpha over 2 over margin of error all squared. So her approval rating was 0.62 times 1 minus 0.62. Now Z alpha over 2, we're just going to stick to a 95% confidence level. And the margin of error was 0.3 or 30%. So this is equal to 10.05. Always round up. Okay, so therefore she most likely polled 11 people. Well, that's a very small sample size. That explains why this range is so large. I don't think I'd be very happy with that. With that kind of approval rating. I wouldn't want it at least 50 and up. Okay, so always remember, for calculating how many numbers in our sample, you should always round up. The politician would like to have a smaller margin of error in the survey. How many people would she need to poll in order to ensure a margin of error of not greater than 10%? Okay, so now all we're doing is changing that margin of error to 0.10. So let's see. That would be better, because then she's going from 60 to, of not greater than 10%. The confidence interval then would be 0.62 minus 0.10 is less than P is less than 0.62 plus 0.10. So that 0.72 is less than P is less than no, that should be 52. Less than P is less than 0.72. So that would be a better. Assuming she's only running against one other person, right? I mean, I would feel better if I had 50. If there's one other person you're running against, I would feel better with 52%. So let's see, how many people should she poll? P hat, Q hat, Z alpha over 2 over margin of error squared. So it's going to be 0.62, 0.38 times 1.96 all over 0.10, and that equals 90.5. So always round up. She should poll about 91 people. to get a margin of error of only 10%. Can I explain anything any better? Yeah.
Why did we have to find the confidence interval?
Sorry?
Why did we have to do the first step to find the confidence
You
interval?
didn't have to. I just did that as an extra. To answer this question, you didn't have to. I just wanted to see what our confidence interval would be. Is there anything else you'd like me to explain? Okay. A machine that produces control arms for a vehicle gas pedal generates pedals that have a length with the standard deviation of 0.08. 30 pedals are tested to see if their lengths are acceptable. The sample mean was found to be 18.2. What would be an acceptable range of lengths for a 95% confidence level? So Z, if we're using 95%, that's going to be 1.96. I guess the magic marker bled through. Okay, so X bar minus Z alpha over 2 times, here I better fix that. It doesn't look very healthy. Sigma over square root of n is less than the population mean, is less than X bar plus Z alpha over 2. Sigma over square root of n. So our mean is 18.2 minus 1.96 times 0.08 all over the square root of 30 is less than mu is less than 18.2 plus 1.96. I didn't want to write that. I want to be plugging in my numbers now. Okay, if you were to calculate, you would get 18.17 is less than mu is less than 18.23. So on the test, you will get 1 mark for the formula, 1 mark for filling it in, 1 mark for the calculation, and then I'm going to ask you to interpret. So be very the wording on interpretation is very specific. We are 95% confident that the, I do that for some, that the confidence interval (18.17) is less than the population mean is less than 18.23 contains the true population mean. So, if they sampled this over and over again, if they did another sample of 30 and did these calculations, and they did another sample of 30 and did these calculations, or another, that 95% of those samples would contain the true population mean. Right? A tire manufacturer, can I explain anything better on that one? tire manufacturer is getting ready to test a new production process. The machine produces tires that have an inner diameter of 16 inches with the standard deviation of 20.25 and are normally distributed. How many tires would have to be tested to be sure of a 95% confidence interval with the margin of error of 0.10? So N is equal to Z alpha over 2. They want a 95%, so that's 1.96 sigma squared all over the margin of error. So we have 1.96 times 0.25 all over 0.10 squared, and I get 24.01, but always round up. So it'll be 1 mark for this, 1 mark for this, but to make sure that you remember to round up, test 25 tires, and 1 mark for proper rounding in this situation. Just another example on proportion, and that's it. An exit poll is done outside a voting location. People have just voted are asked if they will state who they voted for. In a close election, an exit poll states that Larry Liberal has 48% of the vote, Constance Conservative has 46%, with the rest split up among other candidates. The polling firm states that 500 people were polled. What is the margin of error and confidence interval for each candidate if the poll is said to be correct 19 times out of 20? So that's a 95% if you divide by 19 out of 20, if you divide 19 by 20, you would get 95%. Is it possible that Larry might actually be losing? So let's, first of all, they want the margin of error. So the margin of error, if you recall, is for proportion is that part of the calculation of our interval. So they're asking us to calculate it separately first, so that's what we'll do. Is Z alpha over 2 square root of P hat Q hat all over N. So this is for Larry. We'll do Larry over here. And then we'll do Constance. Okay, so this is 1.96 times. Now Larry got 48% of the vote. Times 0.52, and they polled 500 people. That is equal to 0.044 or 4.4%. So this is the margin of error. So we're going to go to calculate the interval. We go 48 minus the margin of error is less than 48 plus the margin of error. And that works out to be 43.6% is less than P is less than 52.4%. How do we interpret this? And I'm emphasizing it because you'll have to interpret it on the test. You say, we are 95% confident that the interval 43.6 is less than P is less than 52.4 contains the true population proportion. And then we'll do constants, and we'll compare the two intervals. ME is equal to Z alpha over 2 square root of P hat Q hat over N. So it's again 95% confidence level. Now she got 0.46, so Q hat is 1 minus 0.46 is 0.54 all over 500, and that is again about 4.4%. So for constants, her interval looks like 46 minus 4.4 is less than P is less than 46 plus 4.4. And we get 41.6% is less than P is less than 50.4%. There's a lot of overlap here, right? So it is possible that Larry could win, since the two intervals overlap. It is possible that Larry is losing. Oh, here. Do you see this 50.4 is inside this interval? Right? So basically 43.6 to 50.4. See that this is where constants, a portion, see that's quite a large portion of her interval lies within his interval. So there's a lot of overlap there. So there's hers is a large portion of her interval lies within his interval. So he could very well be losing. He could very well be losing. She could still win. Plus 48 isn't that much higher than 46, right? A second poll is done later. Of 1,000, ooh, now they're pulling 1,000, 47.5% were in favor of Larry, while 46.5% were in favor of Constant. What margin of error is required in order for the confidence level to be 95%? Now let's do Larry and let's do Constant. Margin of error is equal to Z alpha over 2 p hat q hat over n. 1.96 times the square root of 0.475 this time, 0.525 over 1,000 is equal to about 0.031. Sorry? Thank you. But that's the right answer. Margin of error equals Z alpha over 2 square root of p hat q hat over n, 1.96. Now, constants is 0.465 times 0.535 over 1,000, and that's equal to, again, 0.031. So if you were to convert to write their intervals, you would get 44.4% is less than p, almost wrote the symbol for mean, is less than 50.6%, and this one is 43.4% is less than p is less than. So again, there's a lot of overlap here as well. I don't think that poll helped them very much. It's between Larry and Constance, and right? Can I explain anything else? If you're wondering where that's Z score, that's Z alpha over 2. If I were to really quickly just see, they want, this is 0.95, the 95% confidence interval. And if that's true, then if this is 0.95, then this is 0.025, right? And this is 0.025. Let me double check that, because 1.95, 1 minus 0.95 divided by 2 is, okay? So the Z score for 0.025, if you were to look that up, it's 1.96. And the Z score, sorry, it's negative 1.96. And the Z score for 0.975 is equal to positive 1 point. So that's why we're using those Z scores, right? So if this is our interval, we're 95% confident that the true mean or proportion lies between here and here, then we use, this is the Z score we use. Okay, that's how it ties in together.